Maria decides to invest in her RRSP to prepare for retirement. She contributes $6,000 at the end of each year for 20 years. The account earns annual interest of 5% compounded annually. After the 20 years of contributions, Maria stops adding money to the RRSP and allows the investment to grow with compound interest for another 10 years without withdrawals. At the end of the 10-year accumulation period, Maria begins withdrawing $25,000 at the end of each year for her retirement. The account continues to earn 5% interest compounded annually during the withdrawal phase. What will be the value of Maria's RRSP when she stops contributing at 20 years? What will be the value of the RRSP after the accumulation period? And finally, how long will Maria be able to continue to withdraw $25,000 before the RRSP is depleted? Okay, so we've drawn out the situation for us. We're going to contribute $6,000 for 20 years. We're going to defer for 10 years, and then we're going to start withdrawing $25,000 until we run out of money. So in order to figure this out, beginning with today, we're going to take all of these $6,000 contributions and we're going to move them forward to 20 years. Now, this is an annuity. And in this annuity, we're making 20 contributions. All right. We then move ahead with compound interest to 30 years. Now our rate here is compounded annually. So we've got 10 years times 1 compound per year, so 10 total compounds. And then this amount feeds these $25,000 withdrawals up until a certain time T. And we don't really know what that time is just yet. So we need to first figure out this amount, then this amount, and then here, we're going to figure out our N in our third calculation. Okay, so for calculation number 1, we want to find the future value of $6,000 contributions. We started with no money in that account. The interest rate for this problem is 5%, and we're making 20 annual payments. We're making payments yearly, we're compounding yearly, and this is in end mode. Second part, the compound interest part, we're doing this for 10 years. Our interest rate is still 5. Our present value is what ends up in box number 1. So that's the future value of the previous calculation. Payments are 0. Future value is what's unknown here. Payments per year and compounds per year have to be the same. So they're both going to be 1 because we're compounding annually, and the mode doesn't matter. Now for calculation 3, we're trying to figure out how long this amount of money can feed this annuity. So we're looking for our N. Our interest rate is still 5%. Our present value is the future value from this compound problem. So this amount of money comes forward, it's a future value here. This is a present value with respect to that annuity. Our payments, we're receiving $25,000, but we should be careful If we're receiving those $25,000, this needs to be a negative value because that's money we've given up. So if we're investing $6,000 here, our future value is going to be positive. So this is going to be positive here, which makes this a negative, which feeds a negative up there. And so our signs are going to work out properly. The future value is going to be 0 because we're going to exhaust this fund. We're paying out once per year. We're compounding once per year. And we're in end mode for this annuity. So those are the things we need to calculate. Okay. So for box number 1, we have 20 and then N, 5 and then IY, 0 then present value, $6,000 negative is our payment, 0 is our future value, payments per year are 1, compounds per year are 1. We're already in BGN, so we need to set it to, set it to end mode. And we need to compute now the future value. So our future value is $198,395.72. So 395.72. Now this future value becomes the present value for our next calculation. So just press the present value button. I'll make sure that our interest is 5%, make sure our N is 10, 0 payments, 0 future value. Our payments and compounds are both 1, so let's compute the future value. So this future value for calculation 2 is going to be $323,165.73. So that's how much we have here. And I won't squish the change in there. Now, this is a present value when we talk about this third calculation. So I'm going to press present value. Notice that it's negative, which is good. We get $25,000 payments. Our future value is going to be 0. Our interest rate should already be 5, but we'll put it in there. We don't know what our N is. Payments per year and compounds per year are 1. We already have this set into end mode. And so we compute our N, and our N is 21.30. So what's the final answer? What does this mean? So let's answer each of the questions that was asked. What will be the value of Maria's RRSP when she stops contributing after 20 years? So the answer to number 1 is $198,395.72. That's how much she'll have at 20 years. Next, what will be the value of the RRSP at the beginning of the withdrawal phase or after the end of the accumulation phase? So what is this number here? We found that to be $323,165.73. So that's how much is after the accumulation phase. And question 3, how many years will Maria be able to withdraw her $25,000 annually before the RRSP is depleted? Well, we found our N to be 21.3. So she'll be able to take 21 years with full $25,000 withdrawals. And she'll be able to take 1 year with a partial withdrawal. So 21 full withdrawals of $25,000, 1 partial withdrawal. So 22 total years of being able to withdraw from that account.